in this series of videos, we're going to learn how to analyze electric circuit. So before we start, let's define a few terms. And the first one is the electric current. So an electric current is defined as the rate of flow of charge. So let's say we have this wire, this conductor, and then we have charges that are flowing. So when I take this cross section, for example, and I'll find the rate of charge flow right through this section, right? So then the current is defined as the rate of charge flow. Okay, so the current, which is the unit, will be coulomb per second. Right, coulomb is the unit of charge, and second is time. So in most questions that we are going to deal with, so we have, let's do an example where we have a component and we have current flowing into this component I of t, right? So the same current is going to flow out because we cannot destroy charges, right? We can rearrange them, we can make them flow. So the electron that goes into this component are the same number are going to be coming out. So let's say that the voltage at the terminal of this component we call a V of t, but we are going to define that voltage later on. But right now we are dealing with current, so I'm gonna go slowly and step by step. We are going to define all the terms, and then we are going to be able to solve networks, and gradually we'll start with basic networks, and once you feel confident, then now we can move on to some complicated networks. So the current that is flowing through this component is given by the piecewise function that we are given here. So I of t, which is given by this. So it has sections. So I call this section 1, this will be section 2, and this will be section 3, and if you like, I can call this section 4. This is 3. Section 4, let's say before t equal to 0, right? We have 0 there. So the current is 0, and after 15 seconds, the current is also 0. Okay, so let's write the equation. Let's write the equation of the current through this component as a piecewise function. So I of t, the first section, so let's do section 1. So for section 1, what do we have? We have a straight line, so I of t is going to be in the form of mt plus b. Now m is the slope, so we can find m. Okay, so this is for 0 less than t less than 6. That's section 1. Okay, so now what is the slope? The slope is rise over run. So m, the rise is 12 and the run is 6. Okay, so well, if you wanted to do it step by step, this point is 6 and 12, and this point is 0, 0. So to find the slope m, so we have point 0, 0, and then we have point 6 and 12. Now let's find the slope. The slope is the rise, which is 12 minus 0 divided by the run, which is 6 minus 0, which is 2. So m equal to 2. Now let's find b. So we could take one of these points and plug that into this equation. So at t equal to 0, I of 0 will be m times 0 plus b. And we know that is equal to 0 because at t equal to 0 there is no current. So that means b is equal to 0. So the equation, the current, now from 0 less than t less than 6, I of t is equal to 2t. So we have our first section equation. Now let's do section 2. So section 2, this point is 10 and 12. Okay, so for section 2 we have 6 less than t less than 10, and I of t for that section is constant, so it's 12 amps. Okay, so well, those are given amps. Section 3, so we have 10 less than t less than 15, and the current I of t is equal to negative 10 amps. Okay, and then for t bigger than 15, the current is 0. So when we put it all together, I of t is equal to 0 for t less than 0 is equal to 2t, 0 less than t less than 6 is equal to 12, from 6 less than t less than 10, and then is minus 10 from 10 less than t less than 15, and 0 amps for t bigger than 15 seconds. Now, so now that we know the current, the question now is to find the charge, Q of t. So given the current, what is the charge? So we know that, so now let us find Q of t, right? The charge with respect to t, right? The charge Q of t. So we know that I of t is the rate of change of charge with respect to t. So that gives me Q of t will be is the integral of the current. So integral from negative infinity to t. Okay, Q or I of x dx. Okay, we have to introduce a dummy variable to be able to use that to integrate. Okay, so that meant when I have q0, when I have t0, then q, okay, so I just wanted to make sure that you follow this closely. This step is very important. It's crucial for what we're going to do next. So Q minus infinity. So I of x dx. So I mean, if I integrate, if I plug in t0 here, then I have t0 here. Now, so the reason why I'm doing this, I wanted to put this charge equation into a form that is very convenient for us, right, to find this equation, to put this equation in a very convenient form so that we can integrate the current. So we have Q. So you agree with me in calculus. So when you have integral from a to b, right, of something, is integral from a. So if I put c here, for example, a to b plus integral from b to c. Okay, so since we're dealing with a piecewise function, that's why I'm trying to do this. Put in a form that we're going to use to integrate this piecewise function. So if you agree with me, I can write q of t, which is the integral from negative infinity to t I of x dx. I could write it as integral from negative infinity to t0. I'm going to introduce t0 there. I of x dx plus integral from t0 to t of I of x dx. So the reason why I'm doing this is that I wanted to capture what happens, right, before the beginning of the new interval, right? So the new interval starts at t0, for example. So this is equal to q t0, because q of t0 is going to capture everything, right, before, right up to t0 plus the second term I of x dx, right? This is very important. Okay, so for example, when we're going to talk about capacitors that hold charges later in inductors, but what I wanted to do is to be able to give you this equation, and then that's the equation that we're going to use to integrate this current, which is a piecewise function of time. So I of x dx. So that's the formula that I am after. Okay, so that's the formula that I'm going to use. Now that I have that formula, let's integrate the current. So the current that we have is this. So I'm gonna copy this down below, because that's the one that we are going to use to, that's what we're going to integrate. Okay, so that's the current. Now the goal is to find the charge, right? So the goal is to find, we use this to find q of t. So we know that q of t is integral from negative is q of t0, right? I'm gonna use the formula that we just derived up there. So t0 to t I of x dx. Now let's look at the first. So first one, this is number one. So for number one, so one, what do we have? We have when t is less than 0, q I of t is 0. I of t is 0, so q of t is 0 for t less than 0. Okay, so that's the first. The second one, we have 0 less than t less than 6 seconds. So that I of t equal to t amps. So we can find the charge q of t will be integral. Okay, so q. So now what is my t0? Right, so I need to bring this to your attention. So my t0 is the beginning of the interval, right? So that will give me 0 plus integral from 0 to t of 2x dx. So let me insert some space here. Let me insert some space here. So all right, so we have for the, so let me substitute this. So q of 0, q at t equal to 0 is 0 plus integral from 0 to t 2x dx. So when we integrate that, we have x squared 2x squared over 2, which is x squared, taken from 0 to t. That gives me t squared. Okay, so now, so then from was t 0 less than t less than 6, q of t equal to t squared, right, coulomb. Okay, so we have that. Now let's find the for the next interval. So that's this. So the next one is when we have 6 less than t less than 12 or 10, rather. So I of t equal to 12. So now we need to find the charge. So as I indicated, beginning of the interval is my t0, right? So this corresponds to t0. So that is so this corresponds to t0. So q of t for this is a q of 6, okay, plus integral from 6 to t of 12 dx. So when we integrate, so what is q of 6? Q of 6 is we know that q of t, right? So if you like, I can close this we could close it, right? That's all equal to 0. So q of 6 will be 6 squared plus integral, because q of t equal to t squared, right? So I mean q of 6 here is 6 squared, right, from here. Right, so 6 to t 12 dx. So that gives me 36 plus 12t 12x right? Taken between 6 and t. Okay, so that gives me 36 plus 12 t minus 6. So Q of t for this interval is well, let me write this, is 36 plus 12t minus 72. So that gives me 12t minus 36. So cool. Okay, so that is for 6 less than t less than 10, right? If you like, okay, close them. The interval. So that is this one. Now the next one is when 10 is less than equal to t less than equal to 15. I of t we know is negative 10 amps. So Q of t is Q of t0. So t0 is 10, right? That's the beginning of an interval, right? t0. So it's 10, and then plus integral from 10 to t, that's negative 10 dx. So Q of 10, we'll find it from here. So Q of 10 from the previous one. So Q of 10 equal to 120 minus 36. Okay, so that is equal to 84. So we have 84 minus 10 t minus 10 t minus 10. Okay, so that gives me 84 minus 10t plus 100. So that is negative 10t plus 184 coulombs. Okay, so for 10 less than equal to t less than equal to 15, Q of t is equal to negative 10t plus 184 coulombs. Okay, so and then the when t is bigger than equal to 15, then we know that I is equal to 0. So if you like, we have Q of t equal to Q of 15 plus integral from 15 to t of 0 dx, because the current is 0 there. So that gives me Q of 15, and Q of 15 is equal to negative 10 times 15 plus 184. So that's minus 150 plus 184. So what is that equal to? That is equal to 150 minus 84. 150 minus 1, so that's 34. That's 34. So So then let's put it together all together. So Q of T is equal to Q of T is equal to 0 for T less than 0. And then we have the first one from 0 to 6 is T squared. So T squared from 0 less than equal to T less than equal to 6. And then the next one is negative 12T. So negative 12T, oh no, plus 12T, plus 12T minus 36. So 12T minus 36, that's between when 6 is less than equal to T, less than equal to 10 seconds. Right, remember time is in second, it's expressed in second. So the next one is 184 minus 10T. That is between 10 less than T less than equal to 15 seconds. All these are second. Okay, and the last one is 34 when T is bigger or equal to 15 seconds. Okay, so I plotted, this was plotted. So if we wanted to do it by hand, before I show you what we did by computer. Okay, so we have this point. So it's T squared from 0 to, so this is 84 when T equal to 6. T squared so now when T equal to, so that would be this, so 36, so it's T squared there, and then something like that. And then the next is 12T, so this is T squared. The second one is 12T minus 36. So when I plug in 6 here, 6 times 12 minus 36, that's 84. So 84 here. So it's straight line, right? Well, I'm sorry, that is this is going to be 10 when I plug in 10 here, right? So 120 minus 36, which is 84. So that's this data. Okay, so I say this is 10. So it's a straight line up to there. And then now from 10 to 15, so let's say this is 15. All right, I come down to, so I have 184. Right, that gives me 184 minus 10 times 15. So 184 minus 150, that's 34. So this will come down to 34. So also a line with slope, negative slope, so it should come down something like this. Okay, and then that corresponds to 34. All right, so this is 36 and that will be 34, for example. And then when we reach 15, remains constant after that. Okay, so this is 34. All right, so this is the charge this key of t in coulombs. Okay, the time is in second. Okay, so I did plot this on a computer, and if you look, I plot it on the computer. So let me increase it so you can see. So that's what it is. Okay, so this point is 34. Okay, so thank you.